All right, so we're going to do this review real quick. So, if you see an expression like this, remember the order of operations. So we're going to start off by doing what's in the parentheses. So, for example, 2 plus 5 is 7. 3 plus 7 is 10. Okay, so, yay, there's parentheses. Now we look for any exponents. We've got an exponent right here. Make sure you do that before you multiply. So 7 squared is 49. Okay, won't lie, don't know what 5 times 49 is. 245 minus 10. You'll notice we're doing the multiplication and division step. And then we'll do addition and subtraction. So 235 should be your answer there. All right. Now this one we basically have two options. One is we can turn this into a decimal. This one is nice that way, but really just as easy. If you have something that's being divided, we can multiply. So let me rewrite it down here a little bigger. I'm going to multiply both sides by 5. Now when I multiply and divide, this cancels out. So we've got 4x left. And then on this side we have 125. Well, now we can divide both sides by 4. So we can either leave it as 125 over 4, or as a decimal, that is 31.25. Either one of those is acceptable. Now in class, we went ahead and changed this to a 3, so that this isn't quite such an ugly problem. So we'll distribute here. That's probably our first step that we'll want to do. Plus 6. Let me get a new pen. Sorry about that. Hopefully you skipped that part. 2x plus 6 equals 3x minus 6. We really want to get the x's together here is what we'd like to do. So you can either subtract 2x here, or you can subtract 3x to the other side. I like to keep stuff positive. So I'm going to subtract 2x on both sides. Then all I have to do is add 6 onto both sides. So x equals 12. Now I gave you a warning for 4 and 5. I said, remember, you'll have to factor to solve quadratic equations. Okay? So this one's quadratic, and this one's quadratic. We know that because of the squared part. Okay? So, if we've got this, if there's no coefficient on here, basically all we have to do is figure out what multiplies to 9 and what adds to 6. So it's either 1 and 9 or 3 and 3. Looks like this will add up to positive 6 here. So we're going to say x plus 3 times x plus 3 equals 0. Now all we need is for these guys to equal 0. If one of those equals 0, then the product will equal 0. So set it equal to 0, subtract 3, x equals 3. Normally we'll get two different answers here, but since they're the same, we really only have to do it once here, and we'll only get one answer. All right, this guy is a difference of squares. This pattern basically says, hey, if I just take the square root of both of these guys, I can do it like this. If you forget about that pattern though, you can do it the same way that we did it before. We can do that by, go ahead and call this 0x since there's not one. And we go, okay, well, we've got 6 and -6 that multiply to this, and they add to 0. So that's one way that you can figure this out. But really, it's a pattern that you should have learned in Algebra 1. Okay, now that we've got that, we can set this equal to 0 and set this equal to 0. And when we solve, we get x equals -6 and x equals 6. All right, 10 shirts, 3 pairs of pants, 2 pairs of shoes. I want to figure out how many different outfits we can make. How many choices are we making? We're making a choice for a shirt. We're making a choice for pants. We're making a choice for shoes. That's 3 choices. And we have 10 options here, 3 options here, 2 options here. If I want every single possibility, we can multiply this. That's 30 times 2 is 60. We have 60 options. We can use kind of the same process here. How many 5-character passwords can you create using only lowercase and uppercase letters? So basically we're making 5 choices. I'm choosing the first character, second character, and so on. Well, I can do lowercase letters, which there's 26 of those, and there's uppercase letters, there's 26 of those. Add those together, that's how many letters? 52 choices. And if repetition is allowed, I can just do 52 on each of these. So that's 52 to the 5th. Sorry, that's 52 to the 5th. This is an exponent. And that is a large number. 8, 0, 2, 0, 4, 0, 2. About 380 million choices there. If repetition isn't allowed, it's the same concept. There's still 52 options for the first character, but now there's 51 options because I've already used one up. And then it's 50, then it's 49, and it's 48. So, you also, since repetition isn't allowed, you could have written this as 52 permutations. Okay. I don't care. You can do this either way. But regardless, your answer should be still quite large. All right. Little factorial math here. Value of 90 factorial, 92 divided by 92 factorial. You can try to put this in your calculator. It will give you an error just because these numbers are so big on top and bottom. But we can do this without a calculator. 90 times 89 times 88, etc. This is 92 times 91 times 90 times 89 times 88. All the way down to 1, okay? But we know that these all cancel out when we divide them. So all that's left, we've got a 1 on top and 92 times 91 on the bottom. 92 times 91. Oops. $8,372. All right. You're trying to break into your friend's locker. That's kind of rude. But, you know, it's a 4-number code, 50 possible numbers. Okay? So let's start out by figuring out all of the possibilities. So there's 1, 2, 3, 4 different choices we have to make here. Okay? We can have 50 numbers for the first code, 49, then 48, then 47. No repeats, okay? It would be 50, 50, 50, 50 if we could repeat, all right? So we can either write it like this. We could also write it as like this. Because order does matter on a code like this. Okay? So that's all the different options, okay? But you try one time to break in. So you pick a number, pick another number, pick another number, pick another number. So your odds of breaking in are 1 over 55 million, basically. But your friend is lazy and always leaves the combination on the last number when they open it. So now we don't have to guess the last number. We know the last number. So now we only have to guess the first 3. And not only that, we don't have to pick out of 50 anymore because there's no repeats. We already know one of them. So now it's 49, 48, 47. Again, we could have written this as 49 permutations 3. So, your odds would still be pretty bad. 1 out of 110,000.